Hello, Mr. Collier here. Today we are going to transition and we're going to start talking about something called dynamics. This is episode 1, The Forces Awakens. Yes, the Star Wars puns keep coming. So far this year we've been studying mechanics, and that's the study of the hows and whys of motion, and that can be split into two categories. Kinematics is what we've been doing thus far this year, describing how things move. We've been talking about how something accelerates, how fast it's going, how far away it lands, and we've been doing that in two different dimensions. Now we're going to transition to why things move, and this is called dynamics, and that's what we're going to be studying for the next several months. I've actually already alluded to this in class, and if you stop and think about it, it really does make sense. Why things move can't be discussed without talking about forces. A force is defined as any push or pull capable of changing an object's state of motion. And that's really what this next unit is going to be all about, studying forces and how they can change the motions of objects. So we've talked about vectors several times this year, and force is also a vector. So vectors have magnitude, unit, and direction. And we're going to represent those vectors with arrows, where the length of the arrow is the magnitude, and which way it's pointing represents the direction. So force is going to be just like that. Now we're going to talk a little bit about the history of this, which is going to lead us to, you guessed it, Newton and his laws. But actually, one of the first people to theorize about how things move and why things move was Aristotle. So this is way back in ancient Greece. And he did understand that forces were required to cause motion of objects, and then he split that motion into two types, natural motion and violent motion. Natural motion, according to Aristotle, was straight up or down motion here on Earth. He basically was understanding gravity. And he thought that things either belonged at rest on the Earth or in the sky, and that was the natural state of things. Only through applying a force, an external force, pushing or pulling an object, would something be removed from its natural state. And that moving an object was against nature, so you had to have an outside force, not only to start something moving, but to keep it moving. And that's going to be the big misconception here that we're going to try to clear up as we go through history. So that general belief was held for about 2,000 years until Galileo came along, and he was really big on experimentation and realized that Aristotle was not perfectly correct. He found that there was something called friction that was slowing objects down, and that how something traveled depended on that friction. So for example, you could roll a ball over sand, and you could roll it over stone, and the smoother stone allows the ball to go further, and the sand stops it sooner. So friction was going to be a major player here. And so he had this idea that if we could actually eliminate all friction, an object would travel forever at the same speed. So one of his experiments looked something like this. He would roll these balls down these different ramps, and what he started to notice was that wherever the ball started from was the height that it returned to on the other side of the ramp. And he could change the angle of the ramp, and as he made the second angle more shallow, the total distance the ball went was further, and yet it still returned to the same height. And so he kind of took that to the extreme and said, well, if I then don't ever return it to the original height, it should just be able to travel forever, keeping going in that straight line, again, if there's no friction. And so he concluded that Aristotle was partially correct, and that an object at rest does stay at rest, but that an object in motion would stay in motion if there was no resistance, again, no friction. He called this tendency of an object to keep doing what it's already doing inertia. Now, that might sound familiar, and you might actually know it from another scientist that we're going to be studying. And he related inertia to the mass of an object. More mass, more inertia, and that is true to this day. It was actually this work by Galileo that laid the groundwork for Sir Isaac Newton to contribute what he understood about the motions of objects, Newton's 3 laws of motion, which is what we are going to be studying in great detail in this chapter, understanding how and why objects move. And that's it for this. We're going to pick up with Newton's first law in our next discussion.